I hope everyone's doing well. I am Mr. Ish. Thank you for joining me for this video where I will show you a formalized approach for doing a limit evaluation with a concentration on the use of limit laws. Now think about it in this way. I'm showing you a formalized approach, but many of you can do this in a very much easier way. But for academic purposes, let's look at the formalized approach focusing on limit laws. Limit as x approaches minus infinity, 3e to the power of x plus 2 divided by 1 over x plus hyperbolic tan x. You're going to do this in the formalized approach using limit laws in a piece by piece manner. Focus right here at the very top, 3e to the power of x. The formalized approach requires you to start generating new and new limit expressions. 3 times limit as x approaches minus infinity, I have e to the x. What have I done over here? I've used the constant multiple property of limits, where this constant can be pushed outside the limit and you're evaluating the limit for your function. Plus, now I'm using the sum or the addition property of limits. The limit of a sum is equal to the sum of their individual limits, the sum property of limits. Plus, now we'll create a new limit, limit as x approaches minus infinity 2. Look what I have, a divide. The divide stays, the quotient property of limits. The limit of a quotient is equal to the quotient of their individual limits. All of that makes sense. Create a new limit, limit as x approaches minus infinity, I have 1 over x. That stays. The sum property comes back over here. I won't verbalize it, but you know what it is. Limit as x approaches minus infinity, I have hyperbolic tan x. 3 stays as is. E to the power of x, a continuous function over the domain minus infinity up to infinity. As you put minus infinity in here, you can literally put this value in here using the direct substitution property. What are you looking at? E to the minus infinity, which is 1 over e to the infinity, which is 1 over infinity, and that's 0. Well, 3 times 0, you have a product coming in here, 3 times that. It's a constant multiple property, but along with that you have a product coming in here, the product of these two items, plus what's going to be coming out from here? Limit as x approaches minus infinity 2 must be a 2. Why must it be a 2? What exactly is 2? It's a horizontal line, y equals 2. Limit as x approaches minus infinity, your function is approaching this value right here, your y-intercept, and that's 2. 0 comma 2, it's approaching 2. What about 1 over x? Well, this is not a continuous function. This is a continuous function over entire domain. This is a continuous function, but this is not. It's a discontinuous function. It has a vertical asymptote at 0. You know what it looks like. It's this, your reciprocal function. Limit as x approaches minus infinity, your function is approaching a horizontal asymptote, y equals 0, and that must be the output coming from here. You'll have a 0. Plus, what about this? This right here is a continuous function over the domain minus infinity to infinity. What does its graph look like? It's squeezed between two horizontal asymptotes, y equals 1, y equals minus 1, and your graph looks something like this. Limit as x approaches the value of minus infinity, or the values towards minus infinity, your function is approaching this horizontal asymptote, y equals minus 1, and that must be the answer coming from here, minus 1. All you gotta do is compute that. 3 times 0, 0 plus 2 divided by minus 1, and your end result will be a minus 2, and it should be right. The limit outcome here is a minus 2. We used here the limit laws. Constant multiple property of limits, the sum property of limit, the quotient property of limit, the sum property of limits. Using the limit laws doesn't make your question any more easier or any more harder. It's just a formalized approach. But again, many of you can do this in your head right away without thinking even about the limit laws. That's the end of this video. Thank you.